Hi there, it's been a little while since I've recorded any videos. I've been busy with university stuff, to be honest, and I just haven't really got around to recording videos, but I have been working away at the M62 project in the background all the same, and I was intending to do a video about the new memory expansion card that I'm using, but I thought since there's been so many updates that I should probably, update everyone with a new video about the M62 system. So yeah. So here is in its current state. It's hard to tell from there, but the single board computer has been reworked quite a bit. It has a quad flat pack for the UART. It's still 16C550, but the DIP version apparently is no longer available. Places like DigiKey and stuff. Well, when they have a huge lead time. But the quad flat pack TQFP44, I believe it is, are currently available and easy to get, so that's what I decided to do. And it also freed up a lot of space on the board. And a second strategy, which part of my redesign, is I've implemented a circuit to switch between the bank 0 being ROM, and it switches it to the other half of the RAM in bank 1, because we're only using half of the 32K RAM. So now you can switch the 32K of ROM from bank 0 to now become 32, another 16K of RAM, and that works quite well. That's to bring it more in line and compatible with CPM. Eventually hoping to port CPM to it, and I've seen CPM uses this feature a lot. Another announcement with that is I actually did start writing my own OS. It's called M62 OS, and and that makes use of this switch. Basically, the OS is loaded to 4000 hex, which is bank 1 RAM. When it executes, it switches the bank 0 into a RAM instead, and then it writes the interrupt vectors at the correct places. So basically it overwrites all from 0 to 100 hex with all the jump vectors and stuff. And well, actually it's FF hex, that's where it does it to. And from 100 hex all the way up to 3FFFF is then used for application space when you want to run your application. Although I will be doing a video specifically about the OS eventually. That's still in progress. It has a command line interface rather than a single push button menu system that the BIOS has, and it appears to be working quite well. And what else that has been done is I have VGA card working. I don't know if I did a video on the VGA card. It's actually a combination. It's VGA and an IDE interface. That's a 16-bit IDE interface. Currently using the Combax flash on there. I still haven't got any file system drivers working yet, so right now it doesn't really do anything. And and the outputs on the top, we have a USB here. There's a PIC32 on there doing the video and keyboard subsystem, and yeah, this was designed. The PIC32 circuit was designed by Jeff Graham. I'll put a link to his project and website in the description. he gave me permission to use it in my designs, as long as I, credit him with it, which I am doing. It's it's very nice of him to let me use it. Basically, that's what that circuit does. Is it allows you to use a keyboard, a PS2 keyboard, and a VGA output or composite output. It will automatically select which one, and it interfaces it to UART. So if I pull this adapter out, so basically I have a UART chip under here, and these chips here are the buffer for the high byte for the IDE. Like I said, this is a true IDE interface, so it's full 16-bit. Although I'm thinking the next revision will actually drop down to just a single 8-bit interface, because the SD cards support 8-bit mode. And I was originally testing this with a real IDE hard disk. It worked quite well. I had a 320 gigabyte IDE hard disk running on this system while I was testing it, which was quite nice. But yeah, the USB on the PIC32 circuit has two functions. It's a bootloader for the PIC32, so when you want to update his software, which I don't think he'll be updating it anymore, and it also acts as a USB to UART pass-through, so then you can plug it into the computer and use a terminal program instead of the VGA and the keyboard. You can use them side by side and they work fine. Okay. Yeah, so the changes on the single board computer mainly are you now cannot select which bank the ROM and the RAM are going in, because now the ROM is fixed at bank 0 on startup, the RAM is fixed in bank 1 on startup, which is actually the second half of the RAM goes into bank 1. The first half is selectable to replace bank 0, so bank 0 and bank 1 will become a full 32K of RAM just by writing an I/O output to port 0. I can't remember off the top of my head. I think it's you write a 1 or a 0. Did I write it? Yeah, I wrote it on the silk screen. Yeah. So port 0, you write 0, 0 to get select the ROM, and 0, 1 to select the RAM, and it automatically selects back to the ROM when reset happens. Did some nice little clever circuitry for that. I'm quite happy with that. I've now put the FTDI header at the top, so you can plug it in while it's inside like a card cage. Now when you're selecting the UART base address, you now don't have an option for 00, because that is taken up by the ROM-RAM switch. And the notches are now being cut off on the board themselves, so it's quite an improvement over the previous version. And also in another video I'll be talking more about this, is I have a RAM expansion board, or RAM-ROM expansion board. It can take up to 512k byte RAM or ROMs. There's a couple of issues with this board, so I still need to put it in for a second revision. But the idea was you can have two of these in, and they can take up basically a total of 2 megabytes per board, and you can have two boards in to a total of 4 megabytes on the entire system. But yeah, that all works well. I'll boot it up and give you a quick run through, show you how it's all working right now. But this is just a brief overview. I will go into detail with individual cards later on. Okay, so here we have the screen output from the Terraterm, and it's boots into the M62 BIOS, which currently this is a January 9th version, and it's what I'm using for my development. I eventually will have support in the BIOS for the FAT file system, and then we could load the OS from the FAT file system from there. But for now, while I'm developing the OS, I'm currently writing it into a non-volatile RAM, a 16K non-volatile RAM. Well, actually, it's a 32K, but only 16 is used. And that currently resides on a proto card that I basically, well, I was going to say I built, but it's actually one of my older memory cards that I've, just reused for this purpose. The only difference is I added a jumper to the edge of the card to allow me to write protect the NV RAM. So when I'm happy with the way the OS is working, what I do is I just use the X command to receive it directly to C0000, which is bank 3, which is where the NV RAM resides. And then once that's copied over, I just move the jumper back to protect, and then it acts as a ROM. And yeah, it works quite well from there. Like I said, that's until I get FAT file system working, and then I can stick it on a SD card, or not SD card, I can stick it on the compact flash card. Let's load into the OS. So when I pressed O in that menu, it basically copies it from the non-volatile RAM into bank 1 and then executes it. The first thing the OS does is switches the bank 0 to RAM and writes the vector table. It then looks for the expansion card, and in this case it's actually found the expansion card at the at port C0. This is where the expansion register is going to be. I don't want to talk too much about the expansion card because I'm going to dedicate an entire video with that. So I can type help, and it's all command based, which is really good because I was actually up to like 6 in the morning last night actually updating the command line interface because it was a little flaky by the way it passed the commands, but now it's working great. So here we have the options for restarting. Restart warm will basically restart back into this OS. Okay, and restart cold, it's just like hitting the reset button. We're now back in the ROM. So we go back there. Okay, so, and obviously we got CLS for clearing the screen, we got the help command. See, if I type restart without an option, it will tell me what it does. And what I like is memstat will read the expansion card and let me know if there's a ROM or RAM in those locations. Eventually I'll have it so it will go through each chip and measure the size of it, and I currently don't have a second card in which would do chip 4, 5, 6, 7. There was an issue with the design on that which needs to be addressed for the next revision. Simple mistakes. And so the idea is with this is you can load binaries into the RAM starting at hex 100, and receive in this case works just like the X command in the BIOS, where it receives the binary file from the terminal, but in this case it puts it in at hex 100 onwards rather than letting you choose where you want it to go. And once it does that, it will load it into the memory, which is fair enough. But it won't run it. You have to type execute to run it, and then basically whenever we're running in an application, we can always hit the NMI button to return back to the command line, where we can choose to save a snapshot of the current state, or reload a new program in. It's all basic right now. Like I said, eventually I'm going to be doing a fat file system. So basically, when we type a command that we don't have built in, it will look to see if it's a program, just like Dust does it. So like that. But right now it's an unknown command. But yeah, it's slowly coming together. Anyway, that was a quick overview and the showing of the status of the M62 project right now. It's been a lot of stopping and starting with development for this. Like I said, I've been busy with university, and I'm currently on my reading week, so I've had a bit of time to do some more coding, so I'm happy about that. And yeah, I'm going to be continuing to develop it, and hopefully get something good going on it soon. Yeah, I'll be putting more videos out soon. The next one will be a memory expansion video, which I've had a few requests from that, and if people want to know more about that, then that'd be good, because the way I expanded memory on this board is a little different than the way I did it before. The other way that I shown last time, I used an obsolete chip, and I decided to refine the design to use chips that everyone can use. So I think I found a nice balance of features and availability of parts. So anyway, more of that will be coming up soon. Anyway, thank you for watching, and I'll see you again soon.